Um, when the equilibrium constant of a reaction is unknown, let's say look here that you have to calculate Kc, but then what is given? If you are given the initial conditions, you are doing a reaction of hydrogen reacting with iodine to form Hi. It's an equilibrium, it's a reversible reaction. But you are given how much you are starting with, how much hydrogen you are taking, how much iodine you are taking, and then one of the concentration values at equilibrium are given, then we can find out Kc. And how do we do that? So look at this question. In this question, they have given you initially you started with 1.000 times 10 to the negative third molar hydrogen gas, 2.000 times 10 to the negative third molar iodine gas, and since these are the initial conditions, the reaction has not started yet, so we're going to put product concentration as 0. What else is given? We are given the concentration of Hi, the product at equilibrium, which is this 1.87 times 10 to the negative third. Now this is called I stable. I stands for initial conditions, C is change, and E is equilibrium. Now look at the stoichiometry of the reaction. For 1 mole of hydrogen and 1 mole of iodine consumed, you're making 2 moles of hydrogen iodide. So assign a variable, let's say x, to represent the amount of hydrogen that reacted. So we're going to put negative x here. Why did I put negative? Because it's getting consumed. Look at the stoichiometric ratio, 1:1. So that means for every x moles of hydrogen, you need x moles of iodine. And since again it's a reactant is getting consumed, it has to be a negative sign. And for every 1 mole of each reactant, you're making 2 moles of product. That means it is 2x plus 2x. Now, using this table, the one I did so far, what I can do is I can find the value of x, because initially we started with 0, and at equilibrium I have this much concentration. That means it must be coming from here. So I can say 2x, basically 2 times x is forming. So the change is, in this case, 1.87. So basically your 2x is equal to 1.87 times 10 to the negative third. Or another way of saying is that you started with 0, you have this at equilibrium, that means this must have been formed here. Now this is the value of 2x, then what will be the value of x? If you have 1.87 times 10 to the negative third, you divide by 2, and when you divide by 2, I'm going to again write it down in the scientific notation, and it is going to be 9.35 times 10 to the negative fourth. That means I'm consuming 9.35 times 10 to the negative fourth of hydrogen and 9.35 times 10 to the negative fourth of iodine. And you can think like that. If I'm consuming this much, I'm making double of it, and the double of 9.35 times 10 to the negative fourth is 1.87 times 10 to the negative third. So can I find the equilibrium concentration? Initially I started with this, I consumed this much, then how much is left? It is 1 times 10 to the negative third minus 9.35 10 to the negative 4, and it will be 6.5 times 10 to the negative 5th. Subtract these two numbers. I started with this, I consumed this much, how much is left? 1.065 times 10 to the negative third. Now I know all the equilibrium concentrations. So then can I calculate Kc? Yes. All I have to do is to first write down Kc expression. Kc will be equal to concentration of products raised to the power their stoichiometric coefficients divided by the concentration of the reactants. And then I'm going to plug these values. Hi is 1.87 times 10 to the negative third raised to the power second, 6.5 times 10 to the negative fifth times 1.65 times 10 to the negative third. And if you will solve it, it should come out 51. Now here, initial concentrations were given. One of the equilibrium concentration was given, and we found out Kc. What if, look at this next problem, what if Kc is given? Here the Kc is given, and what they are telling you is to find the equilibrium concentrations. So I'm going to make again my ice table. Here is my hydrogen, iodine, 2Hi. Initially, I started with 1 mole of hydrogen. 1 mole of hydrogen in 1 liter makes it 1 molar. 2 moles of iodine in 1 liter makes it 2 molar. And initially, it is 0. If I assume the change is negative x, 2x, and equilibrium 1 minus x, 2 minus x, 0 and 2x. My Kc is equal to concentration of Hi, which is 2x raised to the power 2, divided by the concentration of reactants, 1 minus x times 2 minus x. And what is my Kc value? Kc value is 50.5. Now this is a quadratic equation. So I'm going to simplify this quadratic equation. What you have to do, you multiply, it will become 4x squared equals 50.5 times 1 minus x times 2 minus x. You are going to multiply foiling algebra, multiply by 50.5, make a full quadratic equation, and when you're going to solve that quadratic equation, you will get 2.323 and 0.935 as your answers. Now I know that 2.323 is not possible. Why? Because if I'm starting with 2 molar, I cannot have more left. So that means my x value will be this. So if I know the x value, I can find out the equilibrium concentrations. Hydrogen will be 1 minus 0.935, which is equal to 0.065 molar. How much iodine will be left? 2 minus 0.935, which is 1.065 molar. And how much hydrogen iodide is present at equilibrium? 2x, which is 2 times 0.935 equals 1.87 molar. So here you can find out the equilibrium concentrations if Kc is given.